From the vast expanse of space, Earth appears as a tiny blue sphere, a solitary oasis in the cosmic desert. This pale blue dot, as Carl Sagan famously called it, is our home, a place of extraordinary beauty and complexity. But have you ever stopped to wonder how this remarkable planet came to be? How did a swirling cloud of dust and gas transform into the life-sustaining world we know today? The story of Earth's formation is an epic saga, spanning billions of years and involving a series of dramatic events. It's a story written in the rocks beneath our feet, the air we breathe, and the very cells that make up our bodies. This essay will take you on a journey through time, exploring the key stages in Earth's evolution, from the violent birth of our solar system to the emergence of life and the development of human civilization. We will unravel the mysteries of our planet's past and gain a deeper appreciation for the delicate balance of conditions that make life on Earth possible. Our story begins roughly 4.6 billion years ago. Long before Earth or even our Sun existed, a vast cloud of interstellar gas and dust known as the Solar Nebula drifted through the Milky Way galaxy. This nebula, a remnant of previous generations of stars, contained all the ingredients that would eventually become our solar system. Something disturbed the peace of this cosmic cloud, perhaps the shockwave from a nearby supernova explosion. This disturbance caused the nebula to collapse in on itself under its own gravity. As the cloud contracted, it began to spin faster and faster, like a figure skater pulling in their arms. At the center of this swirling maelstrom, the material became incredibly dense and hot. Eventually, the temperature and pressure reached a critical point, igniting nuclear fusion and giving birth to our Sun. The Sun's powerful gravity began to pull in the surrounding material, clearing out a large empty space around it. While the Sun blazed at the center of the newly formed solar system, the remaining gas and dust in the surrounding disk began to clump together. This process, called accretion, is driven by electrostatic forces and gravity. Tiny dust grains collided and stuck to each other, forming larger and larger particles. Over millions of years, these particles grew from pebbles to boulders to planetesimals, bodies hundreds of miles across. The early solar system resembled a cosmic shooting gallery, with planetesimals constantly colliding, merging, and sometimes shattering into pieces. In the inner solar system, where Earth was forming, temperatures were too high for volatile compounds like water and methane to condense into ice. As a result, the inner planets, including Earth, formed primarily from rocky and metallic materials, making them relatively small and dense. As Earth continued to grow through accretion, its interior became incredibly hot due to the energy released from radioactive decay and the constant bombardment of planetesimals. This intense heat melted the planet's interior, causing a process called differentiation. During differentiation, denser materials like iron and nickel sank towards the center of the Earth, forming its core. Lighter materials, such as silicates, rose to the surface, forming the planet's mantle and crust. This process created Earth's layered structure, much like a cosmic onion. The formation of Earth's core was a pivotal event in our planet's history. The molten iron core generates a magnetic field that surrounds our planet, protecting us from harmful solar radiation. Without this magnetic shield, life as we know it would not be possible. The early Earth was a hellish place, covered in a magma ocean and bombarded by asteroids and comets. Volcanic activity was rampant, spewing lava, ash and gases into the atmosphere. These volcanic outgassing events released water vapor, carbon dioxide, nitrogen and other gases that would eventually form Earth's early atmosphere. This early atmosphere was very different from the one we breathe today. It lacked free oxygen and was much denser, creating a greenhouse effect that kept the planet extremely hot. Over time, however, the Earth began to cool, allowing water vapor in the atmosphere to condense and fall as rain. The relentless rain filled the planet's low-lying areas, forming the first oceans. These early oceans were acidic and hot, but they would eventually become the cradle of life. The stage was set for the next chapter in Earth's story, the emergence of life.